There's another example we've done with the drive testing, which you see the entire map. Actually takes about 3 days to complete the drive testing, and then we can merge all the data together and come up with the entire plot. And then you can also show the coverage of the entire drive routes. And here is just part of the examples right here. One of the drive tests, you can map it with the color-coded RSSI value. So with that, you can actually see the entire NB-IoT legwork performance on coverage, and see if there's any coverage issues or coverage hole that operator can find a way to cover, or the coverage hole in that case. And here's a reading that you can see that with 15 kilohertz reading per inch, 12 reading will combine together to be 180 kilohertz channel for the NB-IoT. All right, and here's the other test we have done. There's a customer that wants to evaluate an area that have the channel of interest right here that they want to build and deploy another NB-IoT signal right here. So at the location right here, they're trying to find out if this location is free of interference or not. However, they found that when the antenna is pointing to one direction, the signal is quite low, it's close to the noise floor at negative 1.7 dBm. However, when they point the antenna to the other direction, they found that the entire noise floor had been raised to negative 107 dBm. So it actually means there's an interference signal that interferes with the NB-IoT legwork. Right. So somehow they will have used the C-wave system to triangulate the interference loss and find out there's an interference antenna that being installed at the middle of a building. Okay, so besides NB-IoT, we have also have the capability to do the measurement on the LoRa as well. Because the phase one actually is using the enhanced power scan function. And for the LoRa itself, the chipset is being set to support the channel bandwidth of 500 kilohertz, 250 kilohertz, and 125 kilohertz, which basically you can use the enhanced power scan to do the power measurement on the LoRa system as well. So you can make use of that to verify the coverage of the LoRa system. And besides that, for the IoT Cat-M, which also known as the Cat-M1 or LTE-M, is designed intentionally for the narrowband LTE. And it's using the same reference signal as the normal LTE. So basically, you can already use the scanner from PCTEL to conduct the measurement on the LTE-M signal and come up with the all the KPIs with the power, RSRP, the RSRQ, CNR to evaluate whether the LTE-M signal is in a healthy situation or not. And we have a customer in US, the operator, which already have launched the LTE-M technologies, and they are actually using the same scanner that they have from PCTEL to do their operations, such as doing the deployment, optimization, and troubleshooting. All right, so as a conclusion, IoT technology is being deployed everywhere worldwide right now. It's easy to deploy due to the low power, it's more cost effective, and the narrowband nature of the IoT signal or network. Application for the IoT itself doesn't really limit it to the cellular communication, but it can also be applied in our daily lives, being widely used. So far we have identified like NB-IoT, LTE Cat-M, LoRa, Sigfox, or even Zigbee, are commonly chosen for the IoT wireless connections technologies. So no matter what, the PCTEL scanner are able to measure all the NB-IoT signal in different connection technologies to provide more complete and comprehensive IoT performance evaluation to the user, rather than using the user equipment to do the same kind of measurement. So customer can make use of the data to optimize or to plan their IoT network more effectively. So that basically concludes my presentation. Thank you for your time. So if you have any question, we're more than happy to answer your question offline. Okay, thank you.